Hello everybody, and welcome to the second video on functions. In this video we simply continue the thread from last time when I introduced functions to you, and we're going to do three things. I'm going to build two examples for you, and the purpose of each example is twofold. First of all, it is nice to have a catalog of examples running as you are doing your homework. So these two examples are just a couple more things you can add to your running catalog of function examples. But also each function illustrates something about the way functions work that I want to illustrate to you. So I'm going to write a function that helps print prime numbers to the screen, that helps us print prime numbers between a given range, like between 2 and 12 or something like that. The next example I'm going to do is building a string find function. So recall that we already have a find function for strings that we've used a few times. The problem with the current find function is that it seems to be compiler dependent. In other words, its behavior seems to depend on which compiler you have, and even which version of which compiler you have. And that is highly obnoxious. Okay, so we'll just write our own string find function that works the way we want it to, and then we can just use that from now on. We don't have to use the built-in function anymore, whose behavior we can never really predict. And finally, I will introduce the concept of a void function. A void function is simply a function that doesn't return anything. So you hand it a bunch of stuff and it doesn't have a return value. It has no output inside the code. And you may be wondering, of what use is such a thing? Like, what use does a function with no outputs have? But it has a few different uses, and the one I will show you in the video today is that you can use it to just print stuff to the screen. Because if all you are going to do is print things to the screen, you don't need a return value inside the code. So maybe I hand you 2 and a 3 and you print their sum, for example. You don't have to give the sum back if all you want to do is print it. So anyway, I'll show you a couple examples of void functions at the end. So recall this previous homework problem, and I think it may have been bonus, although I can't remember, so you all may or may not have actually done this. But what happens is the user gives you a number, and the program prints all of the prime numbers between 2 and whatever the user gave you. So if the user gives you 12, the program should print 2 through 11, all of those prime numbers. So when I talked to you, a couple of you, about how this program should go, you outlined this basic schematic for me, that if you want to print all prime numbers between 2 and what the user gave you, the most natural thing to do is simply to start at 2, go all the way up to the number the user gave, go one at a time, and if what you are currently looking at is prime, then print it. Okay, so unfortunately this English phrase here is not recognized by the compiler. So what you had to do if you built this program was you had to have another loop in here inside of this for loop to check whether or not I was prime. Okay, so checking if a given number is prime requires a loop. So what made this problem challenging for you whenever this was assigned was that you had a loop inside of a loop. You had your outer for loop here, and then you had an inner for loop that checked whether or not I was prime. And so at this point in the course, that may not sound troubling to you or difficult to you. You know, we are used to nested loops now, but at the time, nested loops was sort of a difficult concept. And so one thing you could have done if you knew what a function was simply outsource this checking to a function, and you would avoid having to think about the nested loop structure. So that's what I'm going to do here. I'm going to write a function that does this checking for us, and the looping that checks primeness will be in that external function, and you won't have to worry about having nested loops inside of main. Okay, so what would that look like? So I want a function that checks whether or not a given number is prime. So I want to check if I is prime. So that function will return either true or false based on whether or not the number I give it is prime. So I will name the function isPrime, and if the given number is indeed prime, I will return true. If the number is not prime, I will go ahead and return false. So as I mentioned last time, Boolean functions are nice for just one of two things, right? The number is either prime or not. A number is either even or not. You know, any sort of setup like that sort of calls for a Boolean function. So I have told the compiler what the return value will be. I'm going to return either true or false. I've given the function a name. Now, inside the parentheses here, I have to think about what do I have to give the function in order for the function to do its job. And in this case, if all I want to do is check whether a given number is prime, I simply have to hand the function a single integer. Okay, so this setup is telling the compiler, look, I'm going to create a function. The name of the function is prime. I'm going to give that function a single integer, and what the function is going to do is return either true or false. Okay, so now let's build this function down here. And by the way, you can ignore this red. What this red is saying is that, hey, you said this function is Boolean, and yet I don't see any return values yet. So notice if I just do this, okay, the red disappears. So basically that red is just sort of a premature yelling at you. It's saying you're supposed to return something and you're not. So all you gotta do is say, hold up, just let me write the stupid function first, right, before you yell at me, and that red will disappear. Okay, so now we need to think about, I've given the compiler or the computer a number. How do I check if that number is prime? And the algorithm I'm going to use, I saw a few of you using, and this is pretty clever. You simply keep track of how many divisors the number has with a variable called count. So what we're going to do is we're just going to start at 1 and go all the way up until the number, and if what we are currently looking at is a divisor of that given number, or in other words, given number is a multiple of what I'm currently looking at, then I'm just going to record that as a divisor hit and up the value of count by 1. Okay, so we're just starting at 1, going up to the number that we are interested in, and just tracking how many divisors we see. The count variable here tracks the number of divisors. So at the end of all this, you know that if you have exactly 2 divisors, the number is indeed prime. So we should return true as a response to this statement, right? The number is prime. But if we have more than 2 divisors, so in other words, count is 3 or bigger, we know it's not prime, so we will return false. And now notice that red has disappeared because now I'm guaranteed to return something. I'm going to output something back. Okay, so again, how this function works is I'm going to hand you a number, and for the sake of this function, I'm calling it given number. I'm going to check if that given number is prime or not, and I'm going to use the code that several of you already used on a previous homework assignment, and I will return true if the number is prime, return false if the number is not prime. So now back up here in main, I can just copy this exact program schematic here from the slides. So I can say, I'm going to start at 2, I'm going to go all the way up to n, the number the user gives us, 1 at a time, and if what I am currently looking at is indeed prime. Okay, so if I is prime. So if the statement I is prime is true, right, all of these things, I will print I. So notice this schematic here mimics this exactly, except this English statement right here, I is prime, I've encoded it as a Boolean function statement here. When I feed I into the is prime function, if I get true back, then please print I. So in other words, it is a true statement that I is prime. In that case, print I to the screen. So let's just run this and make sure it works. If I enter 12, whoop, it didn't work. What happened here? Oh, So I said it in English, but I forgot to go all the way up to my given number, right? So let's try that again. Yeah, there you go. Okay. Sorry, so I said it out loud, but I didn't actually write the equals. So you want to start at 1 and go all the way up to given number, including that number. Okay, so before leaving this example, I wanted to mention one more time. I mentioned this last time, but notice this I doesn't match this given number name. But that's okay, because what's happening is when I is 2, then the value of I is 2. That value gets passed to this variable, so that given number has value 2. So as you run this code here, given number has value 2 as you go through all of this. And then back up here in main, I becomes 3, and so then the value of I is 3. So that 3 value gets passed to given number, so that given number takes on value 3, etc. So what's happening here is this variable here is just handing over its value to this variable. It's like the box is tipping over and the contents of this guy's box are just spilling into this guy's box so that they end up having the same value. Okay, so again, these names don't have to match. All that's happening is that I is handing over its value to given number, like a baton handoff in a track relay race or something. Okay, so now let's move on to our next example, building a string find function. So remember that this is how the string find function is supposed to work. You do myString.find, and then you tell it what you're looking for, and you tell it where you want it to start looking. So that 3 is a position number. So what's supposed to happen is you return the first position of what you're looking for inside of myString, where the computer starts looking at 3. That is what the function is doing, but what seems to be compiler dependent is this statement here. If the computer doesn't find what it's looking for, it is supposed to give you a -1 back. But for some of you, that's not the case. And I don't know why, but I do find it highly obnoxious that you know the code should just be the code. The compiler should be irrelevant. Each compiler should just take the code and do what it's supposed to do. So I don't know why certain compilers don't give -1 back, but my reaction is sort of, okay, now that we know what functions are, screw it, we'll just build our own string find function. So I'm going to call it our string find. That will be its name. Let's first think about what that function is going to give back. Well, it's supposed to give back a position, right? Like if you're looking for another string, it's supposed to return the first position of where that occurs. So a position is a number. It's an integer, and -1 is also an integer. So no matter what, this function is supposed to give us a number back, a location of where we were looking for things. Okay, in order for this function to do its job, what do we have to give it? If you think about it, you realize we have to give this function 3 things. The first thing we have to give it is the global string, the string we are going to look inside. So I have to tell it like, hey, I want you to look inside this string, right? And then I have to tell it what I'm looking for. So here's the big string. Here's what I'm looking for. Finally, if you want to mimic what this find function does, you should also tell it where you want it to start looking, and that's an integer. Oops. Okay, so in order for this function to run, you have to hand it 3 different things. The string that you want to look inside of, the substring you are looking for, and where you want the thing to start looking. Without these 3 pieces of data, this function cannot do its job. When this function is done running, it's going to return a position for us, which is an integer. Okay, so let's bring this down here and actually build it. Okay, so how do you do this? How do you make sure that you find what you are looking for and then return the first instance of that? And you need to make sure you start looking from right here. Well, let's just set up a for loop where we start our search at position. So all I'm going to do is start looking where the thing tells me to. I'm going to go up until the length of global string, I'm going to go one position at a time. And what I'm going to do is ask if what I'm currently seeing is substring. So what I'm currently looking at inside of global string, if that is this thing I'm looking for, I'm going to return where I currently am. So what would that look like? This is going to look sort of confusing at first, but let me just type it. How do I actually look inside of global string to see what I'm looking at? Well, this substring here could be something like of length 5. It could be the word hello or something, right? And so the first thing I need to check is where I currently am. So if you've forgotten how the substring function works, you give it a position value and then you give it how many characters you want it to look for. So what I'm saying is, inside of global string, look at the substring that starts at position I and has the same number of characters as this thing I am looking for. The thing is, if that is what you're looking for, then you should tell me that you found it. Okay, so again, this probably looks confusing, but let's just talk this out. This substring function, what it does is it looks inside of global string, and you have to tell it where you want it to start looking and where you want it to end looking. So you give it where you want it to start, and then you tell it how many characters you want it to keep going, keep looking at. And so if you're looking for substring, you should tell it to look for that many characters. Again, if substring has length 5, if it's like the word hello, then you should tell it, search the next 5 characters. So you will start at position I and go all the way up to I plus 5. If that substring that you are looking at, that you're currently staring at, actually equals the substring you are looking for, then you should return this position. If you make it all the way through this for loop without returning anything, that means you knew you didn't find what you were looking for, so you should give me a -1 back. Okay, so again, this function probably looks confusing, but let me build some stuff in main that I can call on, and then we will. And let me actually move. I want to keep this here so I can put the code on Moodle for you, but let me move it beneath so I don't have to scroll so far. Okay, so here's main right here, and here's the string find function. I'm going to just create something. Okay, so what I'm going to see out is our string find. What I want to look inside of is my string. I'm going to tell it to look for an H, and I'm going to tell it to start looking at position 0. So let me run this and see what happens. It printed a 0, and it should print a 0 because the first occurrence of the substring H occurs right at position 0. And same thing if I put like a hi right there, right? It should print 0 again because the first occurrence of the substring hi starts at position 0. So let me change this back to an H and talk through exactly what the code is doing. So I hand my string, substring H, 0 down here. So global string takes on the value of hi there, substring takes on the value of H, and position takes on the value of 0. So in that case, the for loop doesn't do much. I becomes 0. I'm going up to the length of global string, which is 8. I guess there are 8 characters here, one at a time. If what I currently see actually is H, so in this case, H only has length 1. So I'm saying start at position 0, look at the next character, tell me whether or not that's H. In this case, you don't get very far because the very first position has an H in it. So I immediately return a 0, and that's why you see a 0 right here. So one of the reasons I wanted to show you this function is because whenever you run a function, the first occurrence of a return statement the function sees, the function returns that and then quits. Okay, so this for loop didn't run as many times as you sort of maybe wanted it to run. It didn't run global string.length minus position times, however many times this is supposed to run, because as soon as it encounters a return statement, the function just quits. It returns that value and then stops. That's why it didn't return a, let's see, 0, 1, 2, 3, 4 when I told it to look for an H. right? Because you might think, well, this for loop keeps running, so it returns a 0, then it should also return a 4, because there's an h at position 4, but it doesn't, because as soon as a function encounters a return statement, the function just gives you that value back and then stops. So in particular, since I found an h, I never actually reached this return -1, which is why there's no -1 down here being printed. Okay, so to sum up here, let me just repeat. A function will run until it reaches any return statement. As soon as it reaches a return statement, it returns that value and then stops. So when I asked it to look for a little h, this for loop only ran a single time because I found an h immediately and then the function stopped. So if I put like a e right here, 0, 1, 2, 3, 4, 5, it should return 5 and not 7. Because again, return 5 is the first thing it has, F5. Even though there is an E at 7, you don't get to that 7 because the function has already returned a 5 to you. So just to make sure it works like it's supposed to, let me put something that's not in there. Let me ask it to try to find a hello. Alright, it gives you a -1 back because this for loop, you ran it all the way and you never found what you were looking for. You never found that hello. So you got through this entire for loop without returning anything, and whenever that happens, you just return a -1. So you return -1 precisely when you didn't return anything inside of here, and that happens precisely when you did not find what you were looking for. So therefore, this string find function that we built here works just like the one inside C++ is supposed to, the built-in one. It will indeed always give you a -1 back if it doesn't find what it's looking for. And also just to make sure it's working properly, if I tell it to start looking from position 2, I should actually put a different position in there. Let's see what it does. Yeah, now it gives you a 4 back because it doesn't see this first h, it doesn't see this next I, it starts looking from this space. So 2, 3, 4, it gives you that second h position back. Okay, so we've now built 2 examples. The first example, where is it, this Boolean thing, illustrated that you could really streamline main. So back up here, right, main became much simpler to read. So this little schematic here you could implement basically in English. So the first example illustrated that you could streamline main by making main mimic English more closely. And also, of course, this first example illustrated that not only can you streamline the code, you can also streamline your thinking. We were basically saying, like, I don't like having to deal with nested loops, so let me just punt one of those loops out of main into a separate function that I can call on if I feel like it. So this example was sort of a streamlining example and showing that you can take your thinking and break it into different pieces and sort of reassemble those pieces back up inside of main. This string find function example here, what I wanted to illustrate to you was that if you hit a return value, you stop. So that's what this is doing. There are multiple places where you might hit a return value. The first instance of a return value hit, the program returns something and then stops. Okay, so we now have 2 examples under our belt. Let me just finish. Okay, so that's everything we just did. Let me just finish with 2 examples of void functions. Void functions don't have return statements. They don't return anything. And the first example of such a thing you might see is just a print function. Because if you think about what a print function does, like, what would that even be? Would that be Boolean? Well, no, because to print something, you don't need to return true or false. Would it be an integer function? Well, no, because if all you want me to do is print to the screen, I'm not returning whole numbers back to you. I'm not giving whole numbers back to you. So, I mean, like, what kind of function would it be? Would it be a string function? Print or whatever, right? Well, no, because all the function is doing is just printing to the screen. It's not giving you anything back inside of the code. So to print something, if that's all you want it to do, you would use a function called a void. Void simply means I'm not going to give you anything back. I'm going to do this little task that does not require return values. So I want to show you 2 examples of void functions. The first will be to print a one-dimensional integer vector. The second function will print a two-dimensional integer vector. And for the second function, let me point out something that I haven't told you yet. If you have a two-dimensional vector going, then table.size is the number of rows. So you can still use the .size function on a two-dimensional vector. It doesn't give you the total number of entries though, it just gives you the total number of rows. So in this table here, I have 6 entries, but table.size would be 2 for 2 rows. If you also want to know the number of columns, you can do a command like this, table bracket 0.size. The reason that works is because table bracket 0, that just means the list at position 0, which means row 0. So when you calculate the number of entries in the first row, you are simply picking off the number of columns. So there are 3 entries in the first row and also 3 columns. So this will be helpful when I write this second void function here. Okay, so to print a 1D vector, what do we need? Let me just first give it a name, print 1D vector. Well, what you have to hand to the function is, of course, an integer vector. So if you want the function to do its job of printing a vector, you of course have to tell that function what the vector is, right? You have to say, I'm giving you an integer vector. With that integer vector in hand, all you now have to do is write that same for loop that we've been writing over and over again to print a one-dimensional vector. So you see out entry by entry, and if you want to, you can put a space or an inline in between. But there you go. With this function in place here, you don't need to keep writing this for loop all over the place to print a list. You can just call on this vector, or call on this function. So back up here in main, let me just create a one-dimensional integer vector. Call it my list or something. Then let me just fill it with arbitrary things. So so let me just comment this out. I'm not sure what. So for int I equals 0, I less than, I don't know, 35, I plus plus. Let me just throw some stuff in there. My list dot push back I plus 1 or something. It doesn't matter. So I've just populated this vector. Let me now just command print 1D vector. Which vector do you want to print? Well, my list. Oops, I had to capitalize that D. And notice it prints that vector, right? So I plus 1, I starts at 0, so I start by throwing a 1 in there, and then I end by throwing a 35 in there. So I go up to 34, and then plus 1 is 35. Okay, so again, all that's happened here is my list, the values of my list are handed to the values of list. So the computer simply makes a copy of my list and calls it list down here, and then it prints the values of list, it prints the entries of list right here, and then we're done. So again, if you wanted to set up this function as like an integer function or something, it would just be unnecessary. There's no reason to return anything here. It's just a printing task. So like, why would you need to return anything? You know, I guess you could do something like this and make it an integer function, but it's not necessary. So pretty much any function that exists simply to print things to the screen is a void function. So let me now just build a another void one to print a 2D integer vector. If you want to print a 2D integer vector, you of course have to tell the computer I'm going to give you a 2D integer vector. So there you go. I've told it I'm going to give you a list of lists. And now to print a list of lists, we have to do a bit more work this time because you don't know ahead of time what the dimensions of this table is. So you want to do something like this, right? I equals 0, I up to the number of rows, I plus plus. Like you just want to do the same nested for loop thing we've been doing repeatedly for the last few days. You want to just do this. Oops. So how does it go? Cout table I, j, and maybe I'll set my width here at 3 or something, you know, whatever. And then after I'm done, I should. So you want to do something like this, right? That same nested for loop structure we've had. The problem is that you don't know ahead of time how many rows table has or how many columns it has. But if you look back at this thing I just told you, right? If you have a two-dimensional vector, table.size is the number of rows. So let me just say, int rows is table.size. And the number of columns is simply the size of the first row. So int columns is table first row. How many things are in there? Okay, so now I know the number of rows, I know the number of columns, so I can just print like I normally print. So let me come back up here to main and create a vector of vectors, integer. So of course, I had to tell these functions, I do mean integer things here. So if you wanted to print a two-dimensional vector of characters or something, you would have to build a different function, but that's fine. So my table. And just to make this small, so I'm not killing a bunch of time, let me just create a 2 by 2 table. And let me just fill it in by hand. So my table 0, 0, I'll just put a 4 there. My table 0, 1, I'll just put a 3 there. Going on to the next row, 1, 0, I'll put a 5 there. And finally, 1, 1, I'll put a 7 there, whatever. So now I'll just ask the compiler, like, hey, print 2D vector, my table. So what happens here is all of the values of my table get handed over to this variable here, this table, so that table here is acting like my table from above, and the computer just prints table like you would print it normally. So let's just watch that go. What? Zeros everywhere. Whoa. Alright, well the 4, 3, 5, 7 is there. Plus plus. Oh, oops. That should be a J. Okay. Alright. So with an I right there, I guess that turns that into an infinite loop. So let me just, yeah, okay. So again, that was just a typo here. We always have I's keeping track of rows, J's keeping track of columns. Okay. So anyway, with that typo fixed, this nested loop structure is indeed the printing nested loop structure that prints a two-dimensional vector. All we've done is we've outsourced that task to a function. So now back up here in main, if we have another table, like I haven't created another one, but 2D vector, like other table, you know, if other table were created, you don't have to copy and paste this nested for loop structure around anymore. You just call on it like this whenever you feel like it. Okay. So those are all the examples I have. I will take this exact thing that I have here with our 4 examples from this video and post it to Moodle. So at the end of this video, you should be more comfortable with functions because I gave you 2 more examples, right? A Boolean function that checks whether something is prime, our own string find function. You should also have some idea of what a void function is and why they're useful. So in particular here, a void function is useful because we don't really need to return anything. We just hand the function something to print, and then it prints it, and then it's done. We will see more uses of void functions in a day or 2. So this is not the only use of them. It turns out they're extremely useful for functions that pass by reference, not pass by value. But that is a distinction to be made later.